Let me see. So how do I rewrite this?
3 times 2.
Okay. That's 4 times -2. And on the outside, I still have cubed. Cool. So that's one way to do it. You guys could do multiplication with a dot if you want to. You don't have to have a parenthesis. So like somebody already told me, this is, but in here, the last operation I definitely do in here is the, I'm sorry, in here.
Oh.
That we definitely do very, very last, but in here I do the subtraction very last, right, inside. So 3 times 2, 6. Now be careful here.
Oh, sure. It's negative positive.
-4 times -2 is +8.
Oh, yeah.
You guys see that? Is that cool? So any of those ways we just talked about a second ago about how to handle this, you can either just go that, 4 times -2 is -8, minus -8 is +8. That's probably the most direct way to do it. I kind of purposely gave you one that's a little ugly to force you to do some multiplication at the end. What's the next thing I do?
6 plus 8.
6 plus 8. And how do I do that? 14 cubed.
14 times 14. Yeah.
And then times another 14 exactly. So 14 times 14. Yeah, so let's see. 6, 1, 56. 0, 4, 1. We all cool? So it'll be 196
Times 14.
times another 14. Oh yeah. So we go 6 times 4. Carry the 2. 4 times 9 is 36. 38. Carry the 3. 4 times 1 is 4 plus 3 is 7. And the nice thing with the teens, you just write this whole number again. Because 1 times all of those is those things. Just to almost have it grammatically correct what I say. And then you just add those bad boys. Cool. And you can always check yourself, of course, in the calculator. Okay, cool. So I'm not going to give you like crazy long ass things to do. That's just time consuming and busy work. But you will have to do something like that by hand. Cool.
I have a question.
Yeah.
On the homework,
Yeah.
do we ask something like on the last one, on page 80? I have a question.
Oh, from section 1A?
Yeah.
Yeah, which one?
Chapter 1,
Yeah.
number 63. It looks simple, but I don't see any of the provided answers. Correct.
All right. Well, that kind of leads me to the next level here,
Okay.
and then I'll come back and talk about one of the things that students really dislike the most is translating from English to math, right? And I understand because math is a foreign language, and if you don't pick it up early in life, it's definitely harder to pick up later, as you know if you try to take German or French or Spanish in high school or college. It's like, how do these people speak this? Well, because they've been doing it since they were big. But this kind of thing, let me not do that exact problem yet, but this type of thing, is 5 a solution to 4x minus 3 equals 16? Now the reason I like, it's a nice segue, I'm going to kind of jump over the middle part they have in the section, is because it's exactly like what we just did. If I just gave you this is like you were saying earlier, we could solve it to see what x is. But they've given me a possible value for it. What do we do when we have values for variables? We throw them in. Yeah, plug them in. So let's see what happens if I try to plug 5 in. Will this sentence make sense?
No.
This is a mathematical sentence.
You don't have a choice.
And as we all know, some sentences make sense and some don't. So if I throw in there a 5, is that cool? I'm checking to see if this is a solution, if that works as a value for x. So if I do throw that in, 4 times 5 minus 3, is that 16?
No.
So here you get
20.
20 minus 3. 17 is not 16, not a solution.
It's closer to it, probably.
Say again?
It's something closer to it.
Yeah, it's not far off.
Yeah.
It's close. The actual answer is going to be some kind of gross decimal, but we just confirmed, like you said, it is kind of close, isn't it? It's not 5, but it's close to 5. How are we doing so far? This is not the right way to solve equations, by the way. You don't guess something and try it, and guess something else and try it. This is just good if you want to check real quick if something is a solution. You don't have to solve it, then you just throw it in. Then it's not really algebra yet, it's just do the operations and see if it works. So here, you guys try this one here. Is 3 solution to So again, if you know how to solve this algebraically, don't yet. We're not there yet. Do it by plugging that in. That's what I need to see. Behaving it. So this has got a little bit of a twist to it because it's got a variable on both sides. But we don't care. Wherever I see that x, I'm going to throw in there the 3, right? So negative 2 times 3 plus 5, is that 3 minus 4? So sure enough, yeah, this gets negative 6 plus 5 equals negative 1, check. Negative 1 equals negative 1, yay. So 3 is, in fact, 3 is the solution to this. For this equation, there's at most one answer. And then we just found it. So there's no purpose to even solve this thing. I already know it's 3. Somebody else gave that to me, thank you. So yes, 3 is the solution. Cool.
That equation could be true if held another multiple of 3.
Trust me. If you know how to do the algebra here, you only come out with the one possible answer. Yeah. If you put in there like 6 or something, these numbers don't change, but that number did. So it's going to throw the balance off. It's still not going to be true. You guys with me? Sid, how do you know it's not some multiple of 3? It's because to keep the balance of everything, this has to be 3. If you change this piece and don't change these, which you can't, it's going to throw the whole thing off. That's why there's only that one possible answer here. Not to really confuse out of anything, I want to show you what I just said is interesting, because if I have an x squared in an equation, which we're nowhere near having, so don't forget, if I have an x squared in an equation like x squared minus 1 equals 4x, or blah, 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 there's at most 2 possible answers for this. So if I have a cube, there's 3 possible answers, right, and so forth. That's an interesting thing. So why is there only one answer here? Because the x is to a power of 1. That's kind of nifty. Coolness, okay. So it's a little ahead of where we are, but it's a good thing to say right now, just to show you the general idea. All right, so does that help out with that problem you're looking at? Which one was it?
No, but we figured out there is no answer, because the answer's provided, it can't be any of them.
Which one was it?
63.
63.
On page 80. Because 3 times nothing can equal 10.
That's an excellent point to make. They only gave you whole
The
number
options
possibilities,
of 5,
right?
7, and 10 were the options given.
And 10?
Yeah.
So you throw that in, you throw 5 in, it doesn't work, of course. 3 times 5 minus 4 is 3 times 1. But I like what you just did was awesome. You stepped back for a second. You said, all right, math book, I know what you want me to do. But 3 times no whole number is 10. That's a really interesting point to make. If you don't see that, you can still start throwing 5 in, 7 in. But it's really cool to step back and just say, I can see that this doesn't make sense.
So
The
I
more
kept
you
doing
know,
it
the
over
less
and
you
over
gotta
and
do.
over, and I'm like, okay, it's gotta be one of these, but then it dawned on me, it's like, oh, wait.
Exactly, cool, I like it.
But I didn't know none was an option.
Oh yeah, none is
Once I-
definitely, none is always an option. Right. Failure is always an option. They gave us 3 possibles and they failed. They didn't give me anything that works. Cool, I like it. So don't freak out, I'm glad you brought that up. Some of the answers to this might be none. Because how many things could n be in general?
Yeah, I think the answer was not because I didn't.
Gotcha. How many things could n be in general? For any given equation, how many things could this be? Could be anything. Could be an infinite number of things. So they gave us 3 possibilities. It's more likely that it's something else. Okay. So let's take a step back. I want to come back to translating from English to Mathish, right? Let me start off by just asking you a few questions. How's your relationship? So what if I said, so you're making like $11 an hour, say, right? And I say, we got to cut your pay, we got to decrease your pay by $3 an hour. Holy shit, I'm out of there. But how much would you be making now? If you're making $11 an hour, they say we got to decrease your pay by 3. So what did you actually do? Can you set up the math for me that you just did in your head? You're making 11, they're going to decrease by 3. 11, take away 3, exactly. Right? So decrease, when I see the word decrease, it seems to mean somehow subtraction, which makes sense. But why wasn't it 3 minus 11? Because it's decreased by 3. That's what shows up second. You with me? 3 minus 11 was up, then you're paying $8 an hour to come into work. Thanks for letting me come in today. Okay.
But what I did was subtract 10 minus 2.
Doing a little trick I showed before.
Yeah.
If you shift them both by 1.
Yeah.
But you started with this idea and then you
I
adjusted
did,
it.
but I switched it to
Cool.
10 minus 2.
I got you.
Came up with 8.
So the important thing in this section is translating, direct translation. Don't necessarily take it to what you would do to calculate it, but take it just to what it is in math. They'll give you English, you take it to what it is in math. So let me follow that up with this. What is 14 decreased by X? Yeah, so not a big deal there, right? When they start throwing variables in, this is why it's important to kind of know what would you do if it was a number and then you do the same damn thing with the variable. Because what is a variable? It's a number I don't know yet. It's got to act just like any number. Okay, cool. So what about, here's some key words. Can somebody tell me what's the product of 2 and 7?
6. 14. 14.
Because product implies multiplication. Cool. What's the, here's a good one. What's the quotient of 7 and a number? 7 divided by, and now it's up to you. So you can pick whatever letter you like.
X.
Cool. You can be creative. 7 over P. You can use 7 over some Russian letter. You can use 7 over pi out here. Some variable. Well, pi is not really a variable, but let's do it. So what are the other two? What is, when you want to add something, what words could they use?
Addition. So total.
I like it. Total, sum, addition of two things. Increase, right? Increase is better than decrease. We're talking about how much you get paid per hour. went up by, all these kind of things. And what about subtraction? What could you see?
The difference.
We already saw decreased.
The difference.
The difference between? I like it. The most evil way to do subtraction. To have it in English. Let me ask you this. Let me do another, just straight up, no variables or anything. My brother is, let's see. I'll figure out something that actually makes sense grammatically. I make, let's say I make $20 an hour somewhere, and a friend of mine makes $5 an hour less than that. So what's 5 less than 20? You didn't do 5 minus 20, did you? You turned it around, right? See how that's kind of evil? The decreased by it's exactly the same order. 20 decreased by 5, so 20 minus 5. But what's 5 less than 20? It ain't 5 minus 20. We know I got to turn that bad boy around. When I start throwing variables in, we forget that. And when you get to algebra, that's when you start getting like negative side legs for answers, right? How big of a does your garden have to be? Blah blah blah. And you say -7 foot. What? How do you make a -7 foot garden? What is this? Black hole? Some other dimension? I don't know. So how would you do 12 less than a number? Yeah, so give me a variable. Anything you want? P. You like that P. So P minus 12. So be careful. This less sucks. You gotta be careful. Don't get in the order it comes in. Realize that you do have to turn it around, because that's what you would do. 12 less than 20 is 8, not -8. You know you would turn that bad boy around. But the variable kind of hides it. You with me? A little bit? Okay. That's an interesting point, though. How are these two things different? They obviously are definitely different. How are they different? Let's get a value for P. What could P be? Give me a value. 7. What's 7 minus 12? -5. What's 12 minus 7? +5. Oh shit, they're negatives of each other, aren't they? When I turn it around, it becomes the opposite, right? It becomes the negative.
So
Okay, cool.
What if
So
you
that's-
swap the number and the 12 in that? So if it was a number
That's what I'm
less-
saying right there, yeah.
Yeah?
So this couldn't possibly be the right answer here. You with me? It's got to be this way. So order does matter, and you got to, the less than is the evil one. It changes the order that the problem gives you to two things. You with me? So let me give you one with only variables. What is y less than, not y, Jeff, z.
Z minus 1.
Z minus y. So less than, just keep that in mind. Less than is the only one that really turns it around. Everything else is the same way. If I said, what's the difference between a number and 3? Careful.
The number -3.
Yeah, it'd be like n minus 3 or whatever variable you like. It's only the less than that we know from English I'm supposed to turn it around. I'm 5 years less old than my brother, so I'm actually his age minus 5. I'm not 5 minus his age somehow. I have not been born yet. No. Are you guys kind of with me here? That's the only one that you really have to be careful about. Everything else, the product of 2 and 7, you can write in order. The quotient of 7 in a number, 7 first over the number second. It's only the less than that really screws things up. Okay. All right, here's where it gets interesting, when I start doing a few things together. So like, for example, are you guys so cool by that? Have I said, these are little lowercase Roman numerals? That's how I number my examples out. It's just a habit I picked up, so I don't want to say every now and again somebody go, how's that work into the problem? No, it's just the number 4. What about 12 less than the product of 4 and a number. Oh,
4
shit.
times the number minus 12.
Yeah,
Could be something like that. What definitely comes at the end of this problem?
well,
Yeah, and more specifically, minus 12. So I know it's 12 taken away from something. What am I taking 12 away from? The product of 4 and a number. So how do I write the product of 4 and a number?
4x.
4x, I like it. So I understand the thing that a lot of people don't like about math is that you can't be very creative. This is kind of a lame creativity. There actually is a ton of creativity in mathematics. At least now you have a little, you don't have to put x. You can put a little happy face there if you want to. Whatever symbol you want to use there to denote a variable is allowed. Okay. All right, so let me stop talking. Let me give you guys something to work on. How many guys brought this book here today? Thank God. I don't have that many copies of it. I want you to do. So it's section 1.8 exercises. I want you to do the even ones, just so we can get through them and keep going. When I come to your row, let me know if you need a copy. Anybody here need a copy of this first row? Multiply. Quotient means 5. Anybody here need a copy? You guys all have the book? Anybody here need a copy? Can you pass that one down? Anybody here? Anybody here? Anybody here? Right in the back. Oh, Andy.
Is that even or odd?
Even. Just because. Do you want? Oh, page 21. Oh, cool. And again, you guys can work together if you want to. Be alone.